Hello class, welcome to this video on GR 4.1, cross-sections of 3D solids. So we're going to look at a few solids here. So we're going to identify the first, we have two solids here, and are they a prism or a pyramid? Well, these are both prisms. If you look at the base, you have two bases. In this case, you got rectangular bases, right? Two bases, one on either end. And then you got the base here, and you got a base there. They're identical. So squares are rectangles. So they're rectangular prism for the first one, and then the second one is a square prism or a cube. But either way, they're both technically rectangles because a square is a rectangle. So the shape of the base, I put rectangle for both of them. Now, if I slice parallel to the base, right, where it's parallel, notice that the shape that I get is going to be rectangular, right? I'm going to get a rectangular like cross section. So let's show you that in the animation. So if I slice parallel, you can see I get that rectangular cross section, or square if it's a cube, right? Now, what if I slice it perpendicular? That means I rotate this plane perpendicular, so it's 90 degrees to the base, right? It's a right angle to the base. So let's figure out what that's going to look like. All right, so if I slice it, if I rotate this plane 90 degrees, so it's perpendicular, you can see I also get a rectangular cross section, although it's a different size. All right, so for both of them, it's going to be rectangles. Obviously, for the second one, it's going to be a square rectangle. Now, if I look at the next object here, it's a triangular prism. It's not a pyramid because notice that the base here is the same. You have two bases, one on either end, and the base is a triangle. Now, if I slice parallel to that base, so if I slice it like this, where it's parallel, notice that I will also get a triangular cross section. So let's show you that. All right, there you go. So that's a triangular cross section that you can see no matter where I slice it along the length. Now, if I rotate that perpendicular, so it's at a 90-degree angle, what's that going to look like? All right, so it looks like you get a rectangular cross section, and you can see that there. So there's a rectangle. All right, so let's look at the next one. The next solid is a hexagonal prism. Notice that there's two hexagon bases, right? That's on either end, right? That's a hexagon. If I slice it parallel to that, let's see what that looks like. Yep, you see that characteristic. We see that same shape for we get that hexagon-like shape for if I slice it parallel. Now let's rotate that, let's rotate this 90 degrees to see what shape we get. So let's do that. So if I do that, we can see that we get a rectangle. So that's if I slice it perpendicular. So if this is parallel, and then for example, this is perpendicular or 90 degrees, we can see we get that rectangular shape, and that's hard for me to draw it. So we get a rectangle. Now, if I look at the next one, this one is a prism-like object. So it's not quite a prism. The reason I refer to it as prism-like is because it has two bases like a prism, so one on either end. In this case, the base is a circle. So if I slice parallel to that, then you notice that you get a circular slice, but let's show you that in animation. There you go, you get circular slices there. If I do perpendicular, rotate that 90, let's see what we get. All right, and looks like we get a rectangle. You can see that. All right, so that's how it looks like. Now let's look at pyramids or pyramid-like objects. We know that's a pyramid because we have one apex there and we have one base, right? There's not two bases that are identical like it was on either end, like it was for a prism. It's only one base. The base here is a rectangle. So if I slice parallel to that, I'm going to get a rectangular slice as well, but it's going to be smaller, of course. But let's show you that in the animation. So just notice that the rectangles are getting smaller and smaller until it becomes like a point at the very top, but it's a really, really small rectangle at the top. All right, so if I slice parallel, I clearly get a rectangle. Now let's rotate that 90 degrees to see what we get. All right, so let's start full 90 degrees. All right, and then looks like we get a triangle if we rotate that, so it's perpendicular. All right, so it's got to be a triangle. All right, now we have ourselves a triangular pyramid. There's only one base there and one apex, right? One vertex there, opposite of the base. All right, so let's slice parallel to that. And it looks like we get triangular slices, albeit smaller slices than the base. And then we have, let's rotate that 90 degrees. And looks like it's going to be a triangle. But it's a bigger triangle, right? It's a different size triangle. So there's our triangular cross section for perpendicular. All right, now let's look at a pyramid-like object. A pyramid-like object because it has the one base and then it has the apex like the rest of them. So if I slice parallel to that, what do we get? We get circles, albeit smaller circles. All right, now let's look at the next one, a perpendicular. Let's rotate that 90 degrees, see what we get. So distorted. And then at the very top, when you get to full 90 degrees, you get a triangle. All right. And then we have the oddball out, pun intended there, because we have a ball, a sphere. Now this is the oddball out because it is not like the other ones. The other ones are either prism-like or pyramid-like. This one is just in its own category. So this one, technically the base is a point for a sphere, right? It's a point. So when I mean parallel, I just mean that if this were the point on the base on the sphere, then this is the 0 degree line. Then I just want the cross section to also be at 0 degrees. If I want the cross section to be perpendicular, then it has to be at 90 degrees, right? So like this right angle. All right, but notice that if I slice it, and regardless of whether I do parallel or not, I get circular slices, okay? And you notice that as I go from the North Pole to the South Pole, it gets smaller. As I get to the middle, it becomes larger because that's my equator, right? So that's going to be the great circle for that. Now, if I rotate that 90 degrees, then I have meridian lines, right? So let's rotate that 90 degrees. And the biggest version of that is like the prime meridian, right? That great circle in the middle. But either way, it's still a circle. All right. And that is it for the shapes. So let's summarize. We have here prisms and prism-like objects. Remember, this is not a prism, but it's a prism-like object because it has the two identical bases on either ends, like this, right? Notice that if I slice parallel to the base, it's the same shape as the base. Rectangle, rectangle, triangle, triangle, hexagon, hexagon. Same thing here. If I slice parallel to the base, circle, circle. If I slice perpendicular to the base, it's always going to be a rectangle for a prism or prism-like object. And then we have pyramids, pyramid-like objects. If in this case, if I slice parallel to the base, it's still going to be the same shape as the base, albeit is going to be a smaller version of it, but it's still going to be the same shape, same name. Right. In this case, okay, I went ahead and fixed a little typo here. There's a typo in the pyramid and pyramid-like objects, but it should be fixed now. So again, pyramids and pyramid-like objects. So if we slice parallel to the base, it's going to be the same shape as the base, although it's going to be a smaller version of it. So like a smaller rectangle. In this case, a smaller triangle. In this case, a smaller circle. If I slice parallel. Now, if I slice perpendicular, it's always going to be a triangle. Notice for pyramid or pyramid-like objects. Now the sphere, like I said, was the lone ball out, right? The lone one. The oddball out, I guess I called it. But you got parallel to the base, we got a circle and a circle. No matter where I slice it, parallel or perpendicular, it's going to be a circle. So again, just to rehash, parallel to the base for prisms or prism-like, same shape as the base and same size. Perpendicular to the base, always a rectangle. Pyramid or pyramid-like cross sections. Parallel to the base, same shape, although smaller. Perpendicular to the base, always a triangle. And then the sphere, just look above, it's going to be circle if you do for both ways. All right, guys, that's it for the video.